Welcome to this video on number systems. In the previous video, we discussed the decimal expansion of rational and irrational numbers. Today we will solve some questions related to the same. Let's start with the first question. From the given numbers, identify the rational and irrational numbers. You can pause the video to think about the answer to this question. In the first and fourth numbers, no digit or group of digits are getting repeated after the decimal. And the series of points next to them shows that they don't end, that is, they are both irrational numbers. In the second number, the bar above 5 indicates that 5 is being repeated here. And in the third number, the group 847 is repeating after the decimal. Therefore, they are both rational numbers. Friends, let us see this question. Write the given fractions in their decimal form, their decimal expansion. First fraction is 48 by 100. We will write it in this way and solve it using the long division method. Here, the remainder becomes 0 and its decimal expansion is 0.48. Therefore, it is a terminating decimal expansion. 1 by 16. On solving this too, the remainder obtained is 0. Its decimal expansion is 0.0625. Therefore, this is also a terminating decimal expansion. Friends, the third fraction looks slightly different. It is 3 1 by 6. 6 multiplied by 3 plus 1 is equal to 19 by 6. On solving this, we do not get the remainder as 0. And after 2 steps, 6 is getting repeated. Hence, we get the decimal expansion as 3.16666. Therefore, this expansion is non-terminating, recurring. Friends, let's look at the next fraction 29 by 99. If we solve this, we realize that the remainder is not 0. In the quotient, 2 and 9 keep repeating themselves, and the decimal expansion is 0.292929. We can also write this as 0.29 bar. Friends, upon looking at it, you can easily say that this expansion is also non-terminating, recurring. Friends, till now we converted fractions into their decimal form. Can we convert decimal form to fractions? Yes. Now, let's solve some questions related to the same. Express these numbers in the form of fractions, where p, q are integers and q is not equal to 0. There is a method to solve these type of questions, which we will see in the next few steps. Let's take the first number, 0.888. Let's consider it as x. Now we will see whether a number or a group of numbers is repeating after the decimal. Here, the same number 8 is getting repeated. So, we will multiply both sides by 10. After multiplying, we get 8.888. That is, the decimal went one step to the right. Now we can also write it as 10x is equal to 8 plus 0.888. We have assumed 0.888 as x, therefore it will be 10x is equal to 8 plus x. 10x minus x is equal to 8. After solving this further, we get x is equal to 8 by 9. Friends, let's take the second number, 0.27. It is very easy to write it in the form of a fraction. This is a terminating decimal expansion. There is no repetition of any number or group of numbers. Here, because there are only two numbers after the decimal, we will multiply by 100 and divide by 100. And now we will get 27 by 100, which is the fraction form of this number. Friends, let's take the third number, 2.2424. Let's consider it as x. In this number, two numbers, that is 2 and 4, are getting repeated after the decimal. So here we will multiply by 100 and solve it in this way. We get x is equal to 222 by 99. Friends, that's all in today's video. In this session, we solved some questions related to the decimal expansion of rational and irrational numbers. See you in the next video with some facts related to this. Thank you.